Hi, in this video, I'm looking at this question here where we've got an initial deposit of $8,000 was made on an investment taken out over 7 years at a rate of 6.5% per annum with interest calculated monthly, and an additional deposit of $400 is made each month. So if we just stopped at the rate of 6.5% per annum interest monthly, that would be a normal compound interest problem. But because we've got this additional deposit of $400 made each month, that means that we actually have an annuity. And an annuity is a investment system where you start off with a particular amount, in this case $8,000, and then each period the bank adds in their interest, so the value of it goes up a little bit. And then you go and add your own bit of money. So then you go and add on, in this case, $400. And so that'll get you to maybe about $8,500. So the value is increased a fair bit. And then the next period, the bank will go and add in a little bit of interest, but this time, because there's a lot more money in it, it's going to be a bit more than it normally would with a normal compound interest. And then you go and put in your deposit. And then the bank gives you a little bit of interest. And then you do your deposit. And if you compare this with a compound interest formula, compounding interest, if you graph it over time to value, takes a while to get going and then eventually starts escalating up. And it will grow eventually. Whereas with an annuity, because you're adding in more money each time, it quite quickly increases in value and way outperforms a compound interest. So it's beneficial to keep depositing money into an investment, because not only does the value increase significantly, but the amount of interest you're earning also starts increasing quite quickly. So this problem asks us to complete a table showing the progress of the investment for the first 5 periods. So we're not going to do the full 7 years because that would take quite a lot of time. We're going to just do the first 5 periods. And we're going to do this using a recurrence formula. So the recurrence formula for an annuity says that the value at the end of each period is R times the value at the start of the period plus that deposit. So for us, with the problem we got our initial value. Our first period is going to start off with $8,000. Our deposit is nice and easy. It's $400. And then we just need to work out R. Now, R is given by the rule of 1 plus the interest rate per period. So we've got to work out I first. Now our interest rate is 6.5% per annum, and we've got to turn that into a decimal, so we divide it by 100, and our interest is calculated monthly, so we're going to turn this into monthly instead of yearly, so we divide by 12. And so that, if we treat it as a fraction, is going to make our work a little bit easier, 6.5 over 1200. Or if you like a proper fraction that doesn't have a decimal on the top, because you shouldn't, that's 13 over 2400. Your calculator should give that to you if you're using a scientific calculator that converts thirds to decimals. And so our R is going to be 1 plus that interest rate. I'm just going to use the wrong one. I know I shouldn't, but I'm going to. So that's going to be the R we're going to use. And we're just going to leave it like this, because it's just going to be easy enough to put into our calculator anyway. So now let's start up a table, and I'm going to do the table off to the side. So our table is we're going to list off each period. So in this case we have months, and then we're going to list off the principal for that period, for that month, which is AN. And then so that we can work out all of the other things we may want. We added a few extra columns that are normally required. We could go straight to the balance and work that out as one calculation in our table, but we added a few extras. So the next one is the principal plus the interest. And so that's the R times the AN bit, because that's how the bank works out the principal plus the interest. How much interest they pay you is going to be this value, RAN, minus off the principal. So we're going to minus off AN. And so that tells us how much extra we're going to get paid that month. We sometimes quite often include the deposit that we're going to make into there. So that's our value D, just in case that changes throughout the investment. And then finally, we can do our balance, which is the formula RAN plus D. And that'll tell us the value at the end of that period, in this case, month. So if we think about doing up our table, so I'm going to create these columns going a little bit further down. So my first month, my principal is my initial value, my A0, $8,000. Then to work out my principal plus interest, I'm going to do R times AN. So I'm going to have 1 plus 6.5 over 1,200 multiplied by that principal, 8,000. And if we work that out, that gives us a value of $8,043.33. So then we can work out our interest, which is going to be that $8,043.33. And we're going to minus off our principal. So we're going to minus off that 8,000. And that's going to give us how much interest we are earning, which is $43.33. So this month we got just over $43. Our deposit, which is our $400 here, never really changes. It's always going to be $400 unless we decide to increase or decrease that partway through the investment. And that's one reason to keep this column in there, is if partway through it changes. And then finally we can do our balance, which is our principal plus interest, RAN, which is $8,043.33. And we can add on that deposit of $400. And that gives us our balance, which is $8,443.33. So at the end of the first month, our $8,000 has already grown to $8,443.33. So it's already increased by a fair bit. So now let's have a look at the second period. So we're going to do our second period. And our principal this time is our balance that comes down. So I take my finishing balance, the end of the first month is where I start the second month. So now I multiply by the 1 plus 6.5 over 1,200, and I won't show the calculation. We'll just do that up in our calculator. So if we do that, that this time gives us a principal plus interest of $8,489.07. And I got there by taking our principal here and multiplying it by our 1 plus 6.5 over 1,200. I can then work out the interest, which is take this value, $8,489.07, and minus off my principal, $8,443.33. And if we do that, that gives us this time that our interest is $45.74. So we're already gained an extra $2 in interest on top of our amount. So our interest is growing quite well here as well. Deposit is still going to be $400. And so now I can work out my balance by doing my $8,489.07 add on $400, and that gives us a balance for the end of the second month of $8,889.07. So that's the end of the second month. We can now do the third month, and so we take our balance down, 8, 8, 8, 9, and 7. We can multiply this number by our R, which is 1 plus 6.5 over 1200, and that gives us $8,937.22. Subtract off our principal from that amount, and we get our interest, which this time is $48.15. So we're about $3 extra of interest is earned this month on top of everything. Add on the $400, and then so we do our principal plus interest, RAN, plus our deposit $400, and we're going to finish the third month with $9,337.22. On to the fourth month. So month number 4, we bring down our balance, $9,337.22. We multiply this number by 1 plus 6.5 over 1200. So we get $9,387.79. We can subtract off that principal again to work out how much interest was earned. And this time we get $50.57 worth of interest paid into the account by the bank. Add in our deposit into that, and we get a final balance of $9,787.79. One more month to go to get to the end of the fifth month. So our fifth period, we're starting it with $9,787.79. We multiply by 1 plus 6.5 on 1200 to get our principal plus the interest. So we have $9,840.81. Subtract the principal off of that number to work out how much interest the bank is paying, so $53.02. Throw in our deposit, and that means that at the end of the fifth period, we have in the account, oops, not that much, $10,240.81. So it's only taken 5 months to go from $8,043 to $10,240. So we've gained $2,200 basically. Now, a lot of that is coming from the deposit. 1, 2, 3, 4, 5 lots of $400. 5 lots of 4 is 20, so $2,000 of that came from our deposits, which means we're going to have about $200 have come from the bank, which is still pretty good. It's more than you would get on a compound interest investment. So now that we've got our table, let's go back over here, and so that's the answer to part A. We've done our table. Let's now go and have a look at part B. Part B asks us for how much interest was earned after this over this time. So that first 5 months, we want to work out what the total interest was. Now we've already taken a guess that's going to be about $200. But this is where our table helps us having these extra columns, because now all I've got to do is just add up my interest column, because that's going to tell me how much was earned. So let's do that. So we're going to have 43.33 plus 45.74 plus 48.15 plus plus $50.57 plus 53 and 2. So adding all of those up in a calculator is going to give us a total interest of $240.81 the bank paid into our investment. So now part C, what is the value of the annuity at the end of the 5 months? So the value after 5 months is, all we have to do is just read off of our table, this number here. So our value after 5 months is $10,000, $240.81. So there we have it. That's how we use a table to help us work out an annuity using our recurring formula, our recurrence method. And we've got to remember that an annuity is better than a simple compound interest because there's these deposits being made, and that makes not only the value increase quite significantly, but also the interest starts increasing as well. And so the bank starts paying even more in.